Look at this nice problem. Here a identity is given as n factorial over x times x plus 1 times x plus 2 dot dot times x plus n is equal to summation k equal to 0 to n ak over x plus k. From this identity we have to prove that ak equal to minus 1 to the power k nck. This notation means nck, that is combination of k objects selected from n objects. We have to prove it. At first we shall write down this identity, that is n factorial over x plus 1 x plus 2 dot dot x plus n. This is equal to summation k equal to 0 to n over ak over x plus k. Ak that is summation k equal to 0 to n ak over x plus k. We can expand this summation. We get by expanding this summation we get ak, that is a0 for k equal to 0, x plus 0, that is x, plus a1 over x plus 1 dot dot ak over x plus k plus dot dot an over x plus n. This is the expansion of this summation. We can also sum up the terms of this series. For summing up these terms, we can take the LCM of the denominator. LCM of the denominator is x times x plus 1 dot dot x plus k dot dot x plus n times, here also a0 times x plus 1 x plus 2 dot dot x plus k dot dot x plus n plus a1 x plus 2 dot dot x plus k dot dot x plus n plus dot dot ak x plus 1 dot dot x plus k minus 1 x plus k plus 2 dot dot x plus n plus dot dot plus xn an x plus 1 dot dot x plus k dot dot x plus n minus 1. n factorial over this and this over this. Here you can see that the denominator on both sides are the same. Denominator on the both sides are the same. So denominators are can be cancelled out. So these denominators are cancelled out. So n factorial equal to a0 x plus 1 dot dot x plus k dot dot x plus n plus a1 x plus 2 dot dot x plus k dot dot x plus n plus ak x times x plus 1 times dot dot x plus k minus 1 x plus k minus 2 k plus 2 not plus 2 but k plus 1. This is k plus 1 k plus 1 and so on, that is plus dot dot plus n x plus 1 dot dot x plus k dot dot x plus n minus 1. This is so n factorial equal to this. Now we can put on both sides x equal to minus k, because this is a identity and this identity is true for all values of x. This identity is true for all real values of x. So we can put on both sides x equal to minus k. According to our choice, we can put on both sides x equal to minus k. So we can put x equal to minus k, that is x plus k equal to 0 on both sides. If we put x plus k equal to 0, that is x equal to minus k on both sides, this term, that is a0, first term vanishes because first term contains the term x plus k. So as first term contains terms x plus k, so value of this term is 0 because x plus k equal to 0, and next term must vanish because next term also contains the term x plus k, and x plus k equal to 0, so this term also vanishes, and so on, all terms, and plus dot dot. Next terms also vanish because next terms contain the same term, that is x plus k equal to 0, x plus k and also x plus k equal to 0. But ak multiplied by this term only exists. This term only exists, that is this term does not vanish because this term does not contain the term x plus k. You can see that this term does not contain the term x plus k because x plus k equal to 0. As x plus k equal to 0 and this term also does not contain the term x plus k, so this term cannot vanish. This term cannot vanish. Only this term remains, that is this term only remains, and next terms must vanish because next term contain the term x plus k. So next term also vanish because next term all of the next terms contains the term x plus k equal to 0. Only the term this term does not vanish because this term does not contain the term x plus k, where x plus k equal to 0. So all terms vanish except this term. Except this term, all terms vanish. So we have n factorial equal to this term vanishes. So this is 0. This term vanishes. This is 0. Dot dot. Only this term remains because this term does not contain the term x plus k. So this term, only this term exists, ak. If we put x equal to minus k in this term, we get minus k plus 1 minus k plus 1 dot dot minus 1, and its previous term is also minus 2. Next term is plus 1 and its next term is also plus 2 and so on. Last term is here also. Last term is x plus n. So this is minus k plus n. and its next term must vanish because this term also contains the term x plus k. So, this term vanishes. So, this is 0 and its next term is also 0 and so on, and also this term must vanish because this term also contains the term x plus k, where x plus k equal to 0. So, this term must vanish. So, this is 0. So, n factorial equal to ak. We can write this term as minus 1 to the power k, k times k minus 1 times k minus 2 dot dot 2 1, and next part is n minus k. Its previous term is also n minus k minus 1 plus n. So, next part is n minus k minus 1 and so on, and last terms are 2 1. This is the second part of this expression, and also we can write k factorial instead of these terms, because we have already known the formula n factorial equal to n minus 1 n minus 2 dot dot 3 to 1. This is the formula. This is the permutation of n selected. This is the permutation of n objects selected from n objects. This is the permutation of n objects selected from n objects. So, we have n factorial. This is the permutation of n objects selected from n objects, and this is also n factorial equal to n times n minus 1 times n minus 2 dot dot 3 to 1. So, we can write k factorial instead of this, and also we write n minus k factorial instead of this, because those two obey this formula, obey this rule. So, ak minus 1 to the power k factorial n minus k factorial. So, ak equal to n factorial over minus 1 to the power k factorial n minus k factorial. We can multiply numerator and denominator by minus 1 to the power k. So, we get minus 1 to the power k n factorial minus 1 to the power 2k k factorial n minus k factorial. Now, minus 1 to the power 2k is 1, because power of minus 1 is an even number, that is 2k is an even number. So, minus 1 to the power 2k obviously is obviously 1. So, this is equal to minus 1 to the power k n factorial over k factorial n minus k factorial. This is also minus 1 to the power k n ck. This notation is n ck, n c n minus k, n c n minus k, n ck. This notation is n ck, that is combination of k objects selected from n objects. This is the notation. This notation is used for the combination of k objects selected from n object. This is the notation of combination, that is nck minus 1 to the power k multiplied by nck. Thus we have found out the value of ak, that is coefficient value of the ak is the coefficient of this series, and the value of ak is has been derived as minus 1 to the power k nck.